Okay, the next thing in our tour of Mathematica is learning how to use it to simplify and manipulate expressions. So again, if you're doing a lot of math, kind of either for a math class or for your research, it can be nice to basically use the symbolic math power of Mathematica to do some of this algebra and rearranging for you. So here's just some examples of that. Quickly, I'll go through. So here's a long expression, and maybe I want to write it in a simpler way, so I can ask Mathematica to simplify this expression. Okay, so basically it's gathering terms, or it knows that this expression is the same as taking 1 plus x to the fourth. Okay, maybe not so obvious when you look at this, but that's what Mathematica is for. Okay, so the solution to this, a simplified way of writing all of this, is 1 plus x to the fourth. Here's another example. This is a complicated expression. I will remove the semicolon and type it out. Okay. If I want to simplify this, again, Mathematica can gather terms, and all of this, once you do all the rearranging and find your common denominators and things like that, can be simplified as just 1 over 1 plus 3. Okay, so that's just a nice example. Let's do, let's go ahead and evaluate this. I don't know why I did that. I'm not sure. I guess this is just proving that that's true. So this is still a complicated expression, is still equal to all this stuff. When I put 2 in for x, you can see I get something that's the same as what I get when I simplify it. Okay, go ahead and clear that. Notice when I clear it, everything goes blue again. And I will evaluate another complicated expression. That's the same one. And oh, I don't know why I did that again. Oh, sorry. Here, I'm just showing you can do it without saying that this expression is a function of x. That's just a syntaxy thing. So it still works even if, again, I just define this as equal to a variable. Okay, here's a few more algebraic functions. So here's the opposite of that. So let's say I have something like this and I want to actually expand it or bring this to the fourth power inside the parentheses. So it's basically going to do the opposite of what it did before. It's taking a little bit of time to think, but it went ahead and expanded it or put it in a different form. Here I've got 2 different terms added together, and this together built-in function is going to turn them into one term. Okay, so again, it's like finding that common denominator and then figuring out how to add the numerators. I can do the opposite of that. So notice that it didn't do a great job simplifying this because you can cancel out the y's. In fact, it might be worth just seeing if I can simplify it. Well, it goes back to that. So anyways, you can kind of play around with these and see what you can do. Here's another example, a very long expression of things that are r times r to different powers. And let me just go ahead and let you know what that looks like. And here it's going to collect terms. So it's going to try to take a bunch of terms added together and collect them into fewer terms, kind of like it did in this example here, right? Where you had 3 terms and it collected it into one. Same with up here. So, but it's saying collect terms according to this variable s, so in powers to the specified variable. So let's just see what that looks like. So here you can see it's collecting terms that are multiplying s to certain powers. So here all of this stuff is multiplying s to the first power, and all of this stuff is multiplying s to the second. All of this stuff is multiplying s to the third, and then just 1 is multiplying s to the fourth. I can probably switch this to r and get a different type of thing, just to give you an example of what that looks like. So here you can see that's collecting terms in terms of r to certain powers. This is in terms of s to certain powers. That's kind of cool. And again, there's reasons you would use this. It's hard for me when I'm going through all these notebooks to come up with all the different reasons. Okay, and then again, if I wanted to run and also simplify it, so here I'm collecting everything from this with terms of s, which is what I had done here. Now I'm going to simplify it. I can get something even simpler. Okay. And so what this basically did was it took these terms that I guess were collected in terms of s to the 0, and it brought them together. Okay. So again, just doing a little bit of manipulation of equations symbolically on a computer, which is super handy, especially if you're doing kind of pencil paper theoretical physics.